Hidden deep beneath the vast and mysterious Philippine Sea lies a geological marvel that has astonished scientists and captured imaginations worldwide, the Apolaki Caldera. Spanning an incredible 150 kilometers across, Apolaki is the largest known caldera on Earth, dwarfing even Yellowstone and other famous volcanic giants. This immense depression on the ocean floor was long mistaken for a regular seafloor bulge, hiding its true volcanic nature from human eyes for decades. But recent advances in sonar mapping and marine geology have brought this sleeping giant into the spotlight, unveiling a story millions of years in the making. To truly understand Apolaki, one must first recognize the titanic forces that shaped it. The Pacific Plate, the largest tectonic plate on our planet, is an unstoppable engine of geological change. Its constant grinding, pushing, and pulling not only form mountain ranges and cause earthquakes, but have over millions of years carved out some of Earth's most spectacular features beneath the waves. Around 75% of the world's active volcanoes trace their existence to this plate's restless boundaries, creating the infamous Ring of Fire circling the Pacific Rim. The Philippines, situated along this volatile edge, has volcanic activity woven into its very fabric. But Apolaka's story begins far in the geological past, roughly 47 million years ago. This period was marked by a tectonic environment, harsher and more dynamic than today. Beneath what is now the Philippine Sea, a volcanic saga unfolded unlike any other. Relentless magmatic outpouring that lasted almost 20 million years. Imagine molten rock gushing repeatedly to flood an area larger than many countries combined, building the Philippine Sea plateau toward unimaginable heights thicker than Mount Everest itself. This prolonged volcanic activity was fueled by a deep mantle plume, an upwelling of incredibly hot rock from Earth's interior, feeding the gargantuan magma chamber below. Scientists piecing together cores drilled from the seafloor reveal this massive lava accumulation, confirming the region's dramatic formation history. However, the intense volcanic activity could not last forever. Eventually, the magma chamber slowly lost pressure as the inflow of molten rock diminished. The enormous roof of this chamber weakened under its own weight, until, with a cataclysmic collapse, the caldera was formed a circular depression, plunging nearly 5 kilometers deep, complete with steep cliffs and an uplifted central dome where magma briefly surged back. Such a scale of volcanic depression challenges our understanding of Earth's most powerful natural forces. If you picture Yellowstone or Toba, you can start to grasp the potential magnitude of Apolaki. Yet this was something beyond any eruption humanity has witnessed or recorded. Despite the caldera's massive size and violent origins, Apolaki remains eerily silent today. Unlike Yellowstone, which is heavily monitored with seismic stations, satellites, and GPS sensors tracking every subtle shift, Apolaki lies beneath deep ocean waters in international territory. This remote location means scientists have sparse data. There are no direct monitoring stations, and no signs currently indicate any volcanic unrest, no seismic swarms, hydrothermal plumes, or ground deformation. Most experts lean toward the view that the system is extinct, with the rock layers beneath cold and inactive. But science is rarely about absolutes. Could Apolaki be dormant rather than dead? Geological history offers examples where long-dormant supervolcanoes reawaken after millions of years of silence. For instance, Yellowstone exhibits episodic magma surges even today, monitored closely by USGS scientists. Other volcanic systems around the world, including the Mediterranean and parts of Indonesia, have shown signs of revival after long, quiet periods. If Apolaki were to stir, the type of volcanic eruption it might produce depends heavily on the magma's composition. If the magma is basaltic hot, fluid, and low in silicate, the eruption would likely be a slow, steady flood of lava spreading across the ocean floor, devastating marine ecosystems, but unlikely to affect global climate directly. However, If more silica-rich magma were involved, explosive underwater eruptions could occur. Such events would flash seawater into steam, generating powerful blasts, towering ash columns, breaking the ocean surface, and potentially triggering tsunamis, rippling across the Pacific Basin. Historical examples like Toba, Tambora, and Krakatoa illustrate how volcanic activity can influence both regional and global climates through ash and sulfur emissions. Fortunately, no signs point to an active or awakening Apolaki today. Instead, the caldera's true significance lies in the incredible geological processes that formed it and their ongoing influence in this part of the Pacific. Beneath the surface, deep mantle plumes and complex subduction zones continue to shape the region. New microplates are forming as the crust flexes and breaks in response to shifting tectonic forces. This dynamic environment drives ongoing volcanic activity in the Philippines, which hosts some of the world's most active volcanoes like Mayon Tal and Pinatubo. For Filipino scientists and geologists, Apolaki represents more than just an ancient volcanic scar. It embodies a challenge and an opportunity and invitation to explore Earth's hidden megastructures and assert the Philippines as a key player in global geological research. Recent expeditions employing advanced sonar and seismic arrays have expanded understanding of the Philippine Sea's underwater topography, enhancing disaster preparedness and resource management. Scientific exploration also fosters national pride, connecting the Filipino people to the powerful forces that shaped their islands and marine territories. In the broader sense, Apolaki teaches us a humbling lesson about Earth's volatile past and present. It reminds us that the planet's surface is continuously remodeled by forces unseen, often beneath the oceans we seldom explore. The Pacific Plate remains a restless giant, driving not only destruction, but also creation, forming new land, enriching the marine environment, and fueling the volcanic legacy of the Ring of Fire. Should there be concern about the possibility of a future supereruption from Apolaki, current scientific consensus suggests it is unlikely. The magma chamber appears to be frozen solid, and no measurable signs of activity exist. Nevertheless, the caldera's story is a cautionary reminder of nature's unpredictable power and the need for vigilant monitoring of volcanic hazards in the Philippines and across the Pacific. Looking ahead, the ongoing research into Apolaki and similar underwater volcanic systems highlights the intersection of technology, science, and national identity. Filipino expertise and advanced marine technology will continue to uncover the secrets of these deep-sea giants. This knowledge not only ensures better management of natural risks, but also fuels inspiration that, through perseverance and discovery, Filipinos can deepen their connection to the Earth's ever-changing story. From ancient catastrophic lava floods to the quiet pulses of the present, the Apolaki Caldera stands as a monumental chapter in geological history and Philippine natural heritage. It invites us all to ponder the slow, powerful heartbeat of our planet and the tremendous forces that lie beneath even the deepest ocean floors. Thank you for joining this exploration into one of Earth's most astonishing hidden features. Don't forget to like, subscribe, and stay tuned for the next episode, where we will dive into the underwater volcanoes currently shaping the ocean landscape and climate, with profound implications for the Philippines and the world.